Hi, welcome to another Calculus for All video. Today's topic is the average rate of change, and in fact I'm going to be looking at example number 3. This example deals with the function f of x, which equals x cubed minus 4x. And we have 4 questions that we would like to solve dealing with this function. So let's first draw a graph of the function. I recommend, if you have the opportunity, always do that. It gives you a pictorial view of what the algebra is doing. So the first question, that is letter A, says determine the average rate of change between the point x equals minus 2 and the point x equals 2. Well, the first thing I'm going to do is let's just put the point x equals minus 2 and the point x equals 2 on my graph. Now you can recall that the average rate of change is the slope of the secant, that is the line joining those 2 points. That is, I need to know the change in the value of the function and the change in the value of x. Well, here's the change in the value of x. It goes from minus 2 to 2, but you'll notice that the change in the value of the function is non-existent. It's on the same value, the same level. Therefore, since we're looking at the slope between those 2 points, we actually have the answer. The slope between those 2 points is simply 0. So without doing any algebra, we actually know the answer to this question of determining the average rate of change between those 2 points. Well, let's look at it algebraically just to verify. We know the average rate of change is equal to delta f over delta x. So I'll plug in my 2 points. I'll do some algebra, do some house cleaning, and there we have it. Algebraically, we get the same answer as we got visually. That's kind of neat. Let's move on to our next question. A bit more interesting. Same function, same graph, but 2 different points, or at least 1 different point. So x equals minus 2 for my first point, and let me put x equals 1. And again, we want the slope of the line segment, the slope of the secant that joins those 2 points. There's a delta x, there would be a delta f, and there, of course, would be the secant, and we want the slope of the secant. And again, visually looking at the graph, we see that delta x, which goes from minus 2 to 1, it has a value of 3, whereas my y value, my value of the function, goes from 0 to minus 3, so it actually has a change of minus 3, and you can see therefore minus 3 over 3 is minus 1, so just by visually looking at the graph, we know the slope of this line segment, the secant, is minus 1. But algebraically, we'll fall back on that to see if it gives the same answer. So delta f over delta x, I'll substitute my 2 points. I always do final minus initial. I'll substitute those points into my function. Some more algebra, some more house cleaning, and lo and behold, we have what we expected. The slope of that secant line is minus 1. So the average rate of change between x equals minus 2 and x equals 1 is in fact minus 1. Let's jump to question letter 3. Now, this one is almost impossible to draw. Yeah, we can draw the first point, but there's no way I can draw the second point because I don't know what delta x is. It's a variable. So we'll fall back on our algebra. Algebra will always take us to our answer. So average rate of change, delta f over delta x. I'll substitute in my final point, minus 2 plus delta x, and my initial point at minus 2. I'll plug these things carefully into my function. You notice how it's minus 2 plus delta x cubed, minus 4 times minus 2 plus delta x. And likewise for the second part is minus 2 cubed minus 4 times minus 2. So I'll do some algebra, and it still looks kind of scary, but you'll notice that when I simplify, the delta x's can cancel from my denominator and gets rid of some delta x's from my numerator, and it simplifies to this algebraic expression. So it says the way to determine the average rate of change between x equals minus 2 and x equals minus 2 plus delta x, it says, well, this is an expression that will give us that answer. Now, it looks strange, but it's very, very useful for us, because in our next question, it says we want to use this to verify the answers that we got from A and B. Now remember, delta x is just a distance from minus 2. So let's jump into D. Let me just put the answers that we obtained from A and B and then C. There we go. Now we know what the answers are, so hopefully our delta x squared minus 6 times delta x plus 8 should be able to give us the same answers as we got from A and B. So let's just make some room. So for A, our point was minus 2, initial point was minus 2, and our final point was 2. Well, the distance between minus 2 and 2 is 4. So in other words, delta x is equal to 4. So I'm just going to substitute that into my expression. Here we go. Now just a wee bit of algebra and some house cleaning, and lo and behold, we get the same answer as we got doing it the longer way. Likewise, let's look at B. Now we're dealing from minus 2 to 1. Well, that is a distance of 3, so delta x is 3. There's my expression. I'll substitute 3 in for delta x. Again, some house cleaning, and lo and behold, I get the same answer that I got the previous method. So we actually have an alternative way of determining the slope of the CCAT line, and that is, rather than knowing the final point, all we had to know was how far the final point was from the initial point. Sounds strange, but it will be very useful in the next video. Thank you for watching.